Hello everyone, today I am going to explain the introduction of probabilistic analysis of algorithms. So before we go into probabilistic analysis of algorithm, let's quickly review what is algorithm analysis means. When we analyze an algorithm, we try to measure how efficiently it runs and the algorithm performs. There are three cases of analysis: best case, worst case and average case. In best case, when the input is very favorable, when the input is extremely unfavorable in worst case. In average case, when the typically happens on common inputs. Best case is nothing fastest possible performance, and worst case is nothing but worst possible performance, and average case is nothing but expected performance for random inputs. Probabilistic analysis is a mathematical method used to understand this average case behavior. This graph shows how the worst case and average case and best case shows. It inputs size of algorithm and number of operations done. So why do we need probabilistic analysis? In many situations, worst case analysis is too permutation. For example, quicksort has worst case time of big O of n square, but this almost never happens in practice. Instead, quicksort usually runs in a odd big O of n log n. Probabilistic analysis helps us prove and understand this difference. It gives a realistic expected performance, helping us design algorithms that work efficiently most of the time. So the basic idea of probabilistic analysis is straightforward. So instead of assuming one specific input, we assume that the input is random or follows some probability pattern. Assign probabilities to possible inputs and multiply each input's time by its probability and add up to get expected running time. So this is the formula of expected running time. Now let's go to a sample example. To make it simple, imagine an algorithm whose running time depends on order of elements. Some orders may give faster results and some orders gives slower results. So by taking input as A and B and the probability 0.5 and 0.5, but time seconds 2 and 4, by multiplying probability into time, 0.5 into 2 is 1 and 0.5 into 4 is 2, and the total expected time is 3 seconds. So the summary of the probabilistic analysis is used to predict average behavior of algorithms and provides a realistic performance estimate and foundation for average case and randomized algorithms. Thank you.
Mathematical foundation. Now let's move on to the mathematical foundation of probabilistic analysis. This section explains a theory that allows us to compute expected running time and understand the average behavior of algorithm. Moving on to the next slide, understanding the mathematics. To understand probabilistic analysis, rely on basic probability distribution. Use these ideas to measure how an algorithm behaves over all possible inputs rather than just the worst case scenarios. This is the example of discrete probability distribution and this is the example of continuous probability distribution. Where the y-axis shows the probability of value occurring and the x-axis shows random variable. Here the x-axis also shows the random variables. This is an example of discrete probability distribution. The random variables, example, number of comparisons in an algorithm can take only certain values. This gives the expected running time or expected number of operations in algorithm analysis. Coming to this, instead of fixed values, the random variable can take any value in range. The curve f of x represents the probability density function. Basically, the left diagram shows expected value for discrete outcomes and right diagram shows it for continuous outcomes. Both are ways to measure average behavior in probabilistic analysis. Now moving on to the next slide, we have steps in probabilistic analysis. The general steps in probabilistic analysis are as follows. Identify the random behavior in the algorithm or input. Define random variable representing the running time or number of operations. The third one is compute the expected value using probability theory. This expected value gives us the average case running time. Now moving on to the next slide, we have example of quicksort. In quicksort we have to choose a pivot randomly, and the number less than the pivot and the value less than the pivot will be written on the left side and the remaining on the right side. And again we take here as 11 as pivot, and less than 11 are written on the left side and greater than 11 are written on the right side. Same we do like this. And the time complexity of quicksort is big O of n log n. Now moving on to the next slide, we have example expected comparisons for 3 elements. In this example, we focus specially on the expected number of comparisons using probability theory. We compute how often the elements are compared during execution. This method allows us to understand the internal behavior of algorithms more precisely. Now let's move on to the comparison table of pivot positions first, last, random and median. Now take this first, we have time complexity big O of n square, and the advantage is simple to implement and the disadvantage is good in some cases. Now comparing it to the random, then the time complexity is reduced to big O of n log n, and the advantage is good average performance and the disadvantages can be costly to find. Now for example, if array has 3 elements, the result is proportional to n log n, which is reduced from big O of n square. Now moving on to the next slide, we have summary. To summarize this section, expected time represents the average overall inputs. We compute it using the probability theory and helps predict algorithm typical performance.
Hello everyone. Now I am going to talk about the probabilistic applications in algorithms. Now I am going to demonstrate about the algorithms and quicksort, hash, binary search tree, skip list. Yeah, quicksort is a fast divide and conquer sorting algorithm. If the pivot choice is bad, then the time complexity will be of big O of n square. Yeah, if the pivot is good, the time complexity will be of big O of n log n. A skip list is a probabilistic data structure that allows a fast search, insert and delete. A skip list are like linked list with the extra shortcut levels. Now each element have a higher probability, higher level. Yeah, now we are talking about hashing. Hashing is a technique used to store and retrieve data effectively. In hashing, a hash function puts key into slots. Like this one. If the hash function distributes key randomly, the expected time complexity for search, insert, delete will be big O of 1. Yeah, if a hash function distributes key randomly, the worst case time complexity will be big O of n. Okay. If we insert elements in sorted order, the binary search tree becomes a straight line known as a square tree, and time complexity takes as a big O of n. And if elements come in random order, then the tree stays balanced and operations take time complexity as a big O of log n. Yeah, no, these are the time complexities which I have discussed before, and this is the worst case average based on.
Before going to the randomizer algorithms, come back to the probabilistic analysis. In order to use probabilistic analysis, we use knowledge and make certain assumptions for the distribution of inputs and then analyze and compute average case running time. Now I will explain the hiring problem. For example, there is a software company they said to employment agency to hire an assistant. In this case, our goal is to hire an assistant from the agency. The first point is to that the agency will send one person per day. And coming to our current person, if our hiring person is better than current person, we will pay some fee to current person and we fire to the current person and hire the new person. And looking to the algorithm, initially our hiring person, current person is 0, we will make it as best. From the 1 to n members, the agency will send one person per day. If the hired person is better than the current person, we will simply change it. Best equal to y. This is the algorithm will works. Here we can observe that the low cost is if we arrange an interview, it will reduce our cost. That is C of y. CI. Interview cost. Here is the expensive cost is we are hiring from n members. From n members, we are hiring n members. That will be our expensive cost, hiring cost. Then the time complexity is of from n members we are make an interview and then select from hiring person from n members with our hiring cost, that will be our CH into M. This is the hiring problem. Here the worst case is that in increasing order quality, for example, the numbers will be 1, 3, 5, 7, 8, 9. If the first person is 1 initially, then second person 3, the quality is more. Then we can when compared to 1, 2, 3, 1 will be better quality. Then we fired 1 and we select 3. Next 5, when compared to 3 to 5, 5 is better quality. Then we fired 3 and higher 5 until this process going on up to last person. This makes our code more complex. This is the worst case. we can use by using probabilistic analysis, we can reduce our time complexity into this one. Now coming to the randomized algorithms, coming to the definition, that if an algorithm is randomized in its behavior, if the input is produced from the random generated function, input is generated randomly in that running time, then the running time is treated as our expected running time. Coming to the types of randomized algorithms, there are two types of randomized algorithms. One is Las Vegas, and another one is Monte Carlo. Las Vegas is always correct, but it varies sometimes. And coming to the Monte Carlo, it may be wrong, but faster. Example for Las Vegas is quicksort, and example for Monte Carlo is primarily testing. What is randomized quicksort? Randomized quicksort chooses randomly period at each time. By choosing random period randomly, it prevents our worst case scenarios. If the, for example, if the period is in first position or at last position, it makes our more complexity. By using probabilistic analysis through randomized quicksort, we can prevent the worst case scenarios from big of n square to big of n log n for all inputs. Here we can see the example that we can choose the period as randomly, and it divides and sorts our array very fast then we choose the period first or last. What are the advantages? Coming to the advantages, it avoids worst case scenarios like adversarial inputs. For example, first or last. And it simplifies our implementation easy. And it is highly used in practice. And the last one is, it is used in cinematography and optimization and AI and etc. Here we can see the comparison table. This is the analysis style. That means 3 cases: worst, average, randomized. For example, quicksort. If the period location is bad, then our randomness doesn't done anything, and time measures maximum time. For average case, quicksort randomizer input, it randomizes the input and expected time. It gives the expected time. I can set the definition through what the definition is. If I will select inputs randomly and that running time, we can treat it as our expected running time. That is here happened. Coming to the randomizer sort, randomness will be our algorithm and time measures expected time because of same input randomly taken. Coming to the real life application, the real life application is the quicksort in databases. Coming to the real life application, quicksort in databases query optimization. Databases frequently sort millions of records ordered by or grouped by. quicksort is used internally because it is a faster algorithm and it takes n log n complexity, which is best complex faster complexity than the worst case. By using here, we used probabilistic analysis assures that reliable expected behavior because it works on the random information, doesn't takes the complexity more, and it takes a lower memory usage compared to the sorting algorithms. Why probabilistic analysis matters in databases? For worst case, quicksort takes big of n square time complexity. Almost never occurs due to randomness. Databases depends upon predictable expecting runtime. That means it takes randomly the information. Through using the probabilistic analysis, it helps to estimate the indexed operations, and it optimizes the query plans and improves user response time. Here we can observe that worst case will be low and random will be high. Select the table ordered by the column or in the group by group through the random behavior. Here we used the quicksort, which is master of complexity n log n. Thank you. And next, final conclusion that the probabilistic analysis provides a realistic understanding of algorithm behavior. It combines mathematics plus computer science. It is used in performance prediction through randomness, algorithm optimization through decreasing the complexity from worst case to better case, by designing smarter and faster systems of smarter algorithm by using smart algorithms such as the quicksort. Probability doesn't make our algorithm success, it makes them powerful because by taking random variables